Hello my shimmering stars, today I Shaurya Grover welcome you all to this amazing platform of Physics Wallah. Students, I welcome you all to your PW Gulf platform and today we are going to start with your one-shot lecture based upon the chapter Amines. So students, in our Triumph batch, today we are going to complete this one-shot lecture on Amines chapter and I hope so you have seen the lecture very well. Now, let's proceed with the one-shot series. So, in this one-shot lecture, I am going to cover all the important topics such as methods of preparation, then comes your physical properties and at last comes your chemical properties. After this portion, students, we are going to do the diazonium salt part. So, when we did in class, we did in various lectures, but yes, today it is going to be one-shot series. So, you can just open up your notes and if it's not created, you want short notes. So, this video is beneficial for you people. Let's proceed with the very first part. So before starting, let me write the today's target. So the very first segment that we have to finish over here is your, I would say nomenclature part. First of all, we are going to name them. We are going to do the general introduction and the nomenclature with regard to amines. Secondly, students, we are going to cover with your methods of preparation of amines. Thirdly, students, we are going to do physical and chemical properties. Physical and chemical properties of your amines. And at last, my dear students, we shall be doing your diazonium salt topic. Diazonium salt segment. In diazonium salt, we shall be covering the methods of preparation, the physical properties, the chemical properties and so on. Yes, so now let's proceed with the general introduction to the part of amines. What do you think, like what are amines? In organic chemistry, when we come to the word amines, we generally talk about something which is related to nitrogen. But let me tell you, this would be the inappropriate way to define amines. Amines is something which is derived from ammonia. Okay, so when I have to tell you like what do you think what are amines, so amines basically are ammonia derivatives. What are these, ma'am? These are your ammonia derivatives. And now when I am talking about ammonia derivatives, what is ammonia? It is NH3. Everybody knows that. It is what? It is NH3. Now, when I'm I'm deriving something from ammonia, that is something amines. And how I am going to do that? What's the way to do that? So, it's very simple. You just need to remove one hydrogen atom and then you need to add one alkyl group in the place of it. That means you have to replace it, right? With what? With an alkyl group. Okay. So, by that way, you are going to create the degrees of amines. Let me explain it again. Let me give you a general example. So, if I'll say it's ammonia, that means it's NH3. Now, I am going to remove one hydrogen and I am going to add one R group. Now, let me tell you this R group beta over here is your alkyl group. Now, what is an alkyl group if you don't know? Alkyl group is something which is a carbon atom, containing compound. For example, carbon chain, I would say. That is the best way to define it. So, it is either CH3 or it is C2H5, right? It is an alkyl group, a carbon group. Coming to the fact that when I am removing one hydrogen atom and I am adding one R group, what I am going to create? I shall be creating RNH2. Now, this RNH2 is your amine. What it is, ma'am? It is your amine. I hope so this is clear to everybody. Now, let's write down some of the examples of amines. Let's note that down. So, over here, it's a CH3NH2, the very first example. Then comes your next example, that is CH3NHCH3. Then comes your one more example. Let's take an example of C2H5N. Here is CH3 and here is again a CH3. Even I can give you an example based upon the aromatic ones. So, I can give you such example. For example, I can say that, okay, this is also an amine. Okay. That means if I am talking about the R group, I am taking my R group as an aliphatic chain, it will be creating an aliphatic amine. If I am taking it as an aromatic one, it is going to create an aromatic amine. I hope so this is clear to each and everybody of you. If yes, my dear students, then please kindly pause the video and take a screenshot of this particular thing so that I can move on to the next part. I hope so this is fine. Now, coming to the classification of amines. If I'm going to classify amines, I'm going to classify them into three major categories. What are these, ma'ams? Now, the three major categories, students, is your primary amines. It is your primary amines. But then comes your secondary amines, and then comes your tertiary amines. Yes. Now let me explain you what are primary amines, secondary amines and tertiary amines. Primary amines is created when you are going to remove only one hydrogen atom and then you are going to add only one carbon atom or the carbon group over there. That means removal of one hydrogen atom and being replaced by the R group is creating what? Is creating a primary amine. Yes, so in primary amines, we can say that when one hydrogen atom is replaced by R group, right, that creates a primary amine. General examples, if I can talk about, is if it is an ammonia, as you know it is an ammonia derivative, removal of one hydrogen, addition of the R group. So RNH2 is generally what? Your primary amine. Let me tell you one basic thing, it is also referred to as 1 degree amine. Secondary amine is also referred to as your 2 degree amine. And tertiary amine is also referred to as your 3 degree amine. I hope so this is clear to everybody. Now let's take few examples based upon the primary amines. So the examples that I am talking over here is either CH3NH2 I can even take CH3, CH2, NH2. What I did, I just removed one hydrogen atom from ammonia and then I added the carbon chain. Either I am adding 2 carbon atoms chain, 3 carbon atoms, 4 or 1 or whatsoever you feel like. Yes, if I am adding an aromatic one over there and I am removing one hydrogen atom, then also it is creating a primary aromatic amine. I hope so this is clear to each and everybody of you. Now coming to what do you think about secondary amine? Yes, so if I'll talk about secondary amine, when two hydrogen atoms is replaced by 2 R groups. Yes, by 2 R groups, that creates your secondary amine. And in general, if I need to say it, it is like this. This is ammonia, removing of 2 hydrogens, addition of 2 R groups. So this creates RNHR. Now don't think that this R group is attached to hydrogen. No. It is attached to nitrogen atom, right? So let's take few examples of this as well. So that is going to be CH3, NHCH3. I hope so this is also clear to each and everybody of you. Even you can take aromatic ring over here. So if you are taking an aromatic ring, it is going to be like this. I hope so this is clear and fine to everyone. Now coming to what do you think about tertiary amines? So tertiary amines is as simple as primary and the secondary one. When 3 hydrogen atoms are replaced by 3 R groups. That creates your tertiary amine. In general, if you'll be saying it is RNR like this. Now you can take an example of carbon group like CH3N, CH3CH3, or even you can take an aromatic one. I hope so the classification part is clear to each and everybody of you. If yes, please kindly take a screenshot of this part as well, so that now we can move on to the next part, that is the nomenclature segment. As you very well know, it is a one-shot series, it is a revision series. So I shall be completing this particular chapter, in a shorter way so that you can learn it, you can do it a quick revision and you can create your short notes as well. Everybody, if it's done, shall I move on to the next part? I hope so this is clear. Coming to the nomenclature now, let's start with the nomenclature, and here we are going to start with the nomenclature of primary amines. So initially, I'm going to start with the nomenclature of primary amines, and over here, my dear students, just understand this basic part, that when I'm saying primary amines nomenclature, it will be having two kind of names. One is going to be the common name, and another name is going to be the IUPAC name. As you very well know that you people also have two kinds of names. One is your nickname that your best friends or your parents, call you like with a nickname, but you do have a particular name that is used in your schools, in your documents, right? In the same way, each and every organic compound has some common name and even have one or the another, kind of name, that is IUPAC name. See, common name is something which can be changed basically, which is something like if one of the friend is calling me with a nickname, another is calling with a different nickname, but IUPAC name is set with a certain rules and regulations that you very well know, and we have also uploaded a video on the same channel in your PW Gulf platform only. If you want to see, go there, learn the IUPAC rules, and then you can even name a particular compound, and wheresoever you go in the whole world, the IUPAC name is going to remain same. Yes? Okay. Now coming to the fact about primary amines, that is RNH2. What is the common name? It is alkyl amine. It is alkyl amine. And what is the IUPAC name? It is alkane amine. It is alkane amine. Let's take few examples, students. CH3NH2. So the common name comes out to be, here we have one carbon atom, so it's methyl. Hence common name is methylamine. Common name is methylamine. What shall be the IUPAC name for this? It is going to be your methanamine. It comes out to be your methanamine, everyone. Let's take one more example. If I'll say CH3, CH2NH2. So the common name comes out to be two carbon atoms. So it is ethylamine beta. And the IUPAC name comes out to be ethanamine. Ethanamine. I hope so this is clear. Now let me give you one more example whose common name and IUPAC name is same. That is this one, when our R group is an aromatic one. So let me tell you, the common name is aniline for this one, and even students, the IUPAC name is also aniline. It is also aniline. I hope so this is clear to each and everybody of you. Yes? Okay. Please kindly take a screenshot of this as well so that I can move on to the next part of yours. This was about nomenclature of primary amines. Moving on to the nomenclature for secondary amines. Students, just remember, secondary amines can be classified into two major categories, that is your simple amines and your mixed amines. Simple amines and your mixed amines. What do you think are simple amines? First of all, like this is going to be the simple amine RNHR. What is a mixed amine when both the R groups are different? So it's R, NH and it's R dash. So that creates a simple amine and that creates a mixed amine, everybody. I hope so. This is also clear to each and everybody of you. Now let's discuss about the naming part. If you have to name a simple amine, how are you going to do that? So the common name for the simple amine is going to be, now you have same groups, both R groups are same. So you are going to say it is dialkylamine. You're going to say, ma'am, it is dialkylamine. Then what it is going to be the IUPAC name, beta? IUPAC name will be alkyl alkanamine. Alkyl alkanamine. And let me tell you a very funny fact over here, that a fun fact is the thing is here both the R groups are same, beta, right? So let's take an example and name it. So it is CH3 NHCH3, everyone. Yes. So what it is going to be the common name? Common name comes out to be dimethylamine. Common name comes out to be dimethylamine. What shall be the IUPAC name? IUPAC name will be methyl methanamine. Methyl methanamine. I hope so it is clear to each and everybody of you. Now let's discuss with the mixed amines part. Let's take a particular example like of RNHR dash. If I have to write, the common name is going to be alkylamine. I'll let you know which alk will stand where, because both R groups are different. So which will come, what will come where, I'll let you know. IUPAC name, beta, here will be same, but here you need to mention it is N-alkyl alkanamine. N-alkyl alkanamine, right? Now just understand this fact that over here when you are naming a particular compound with its common name, here students you have to use alphabetical order. Here you have to use alphabetical order. I hope so you know what is an alphabetical order. That is as per ABCD rule, A, B, C, D, E, F, G, H. So whatsoever you know, use the alphabetical order. The one with the lower number will be named first, the alphabetical one, and one with the high one will be placed afterwards. Now coming to the IUPAC part, here this alkyl will hold the group which has less carbon atoms. And here alkanamine, alkan will be holding the one which has more carbon atoms. You are going to write that alkyl group over here. Now let's take an example in order to understand this in depth. Let's take a particular example. So if I am taking CH3 NHC2H5, how I am going to name its common name and the IUPAC part, let's see. But a common name again, it is going to be alkylamine. So here we have CH3 and C2H5. Let me tell you one thing, when you have only one carbon atom, students, it is your methyl group. And when you have two carbon atoms, it is your ethyl group. So, you know, when we are naming as per alphabetical order, as per A, B, C, D, E, E comes first. So, ethyl will be named first. Common name is going to be ethyl. Then it will be methyl and then it will be amine. And if I have to name your IUPAC part over here, in IUPAC part, it's N-alkyl alkylamine. Here alkyl will be holding less carbon atoms, and among methyl and ethyl you can clearly observe that the methyl contains only one carbon atom. So it is going to be N-methyl ethanamine. And methyl ethanamine. I hope so this is clear to each and everybody of you. So this is the nomenclature with regard to your secondary amines. Everybody, you can take a screenshot. Now I am going to move on to the fact, about the nomenclature for tertiary amines. Everyone kindly write this down. I hope so this is done. Let's discuss about now your tertiary amines. Let's discuss about tertiary, and in tertiary, let me tell you, generally they're going to give you for simple one only, but tertiary is also beta classified into two major categories. One is your simple, another one is your mixed. Simple one is like R, N, R and R, and mixed one is R, N, R, or even you can take R dash, like this kind of a stuff. Yes. Or you can take double dash. Let's consider all of these are different. Okay. Now, talking about simple one. For the simple one, it's a very simple common name. It is trialkylamine. Trialkylamine. And IUPAC name shall be N comma N dialkyl alkene amine. Why I have put N comma N? That means it is attached to nitrogen atom. The group is attached to nitrogen atom. Let's discuss about the mixed one. The common name over here is going to be alkyl amine, because all of these three are if they are different, right? And now they are again going to be named as per the alphabetical order. What shall be the IUPAC part? So IUPAC part is again the same one. It's N-alkyl alkanamine, or even you can say N-alkyl alkanamine. I hope so this is clear to everybody. Or even you can say in that way, just I have written that N comma N alkyl alkanamine. But this is a very rare situation that they will give you this thing. I hope so this is clear to each and everybody of you. This was about tertiary amines, everyone. Let's now move on to the methods of preparation of amines. Here comes your methods of preparation. So the very first method of preparation that you have to do is reduction of nitro compounds, my dear students. So when you are reducing nitro compounds, what are nitro compounds? For example, this contains NO2 group above over here. Then you have to reduce this into what? The NH2 part. The amines. You have to create amines. So you can create amines in the presence of nickel, platinum or palladium. And then what shall happen over here? Instead of NO2, NH2 will come. So this is the preparation of primary aromatic amine, that is your aniline. Even you can prepare from nitro compounds with the help of Fe plus HCl. And trust me, this is the good way to prepare it, the best way to prepare it. Even you can prepare it with Sn plus HCl. You can prepare it, students, with Fe plus HCl and even with Sn plus HCl. Fe plus HCl is the good way, the best way to do that. Clear? So this is the first method. You can even read out the NCERT highlights that I have mentioned over here. I hope so this is fine, that nitro compounds are reduced to amines by passing hydrogen in the presence of nickel, platinum and palladium, and also by reduction with metals in the acidic medium. Yes, everyone, I hope so the first method of preparation is fine. Let's move on to the next method of preparation. So next method of preparation is by ammonolysis of alkyl halide. First of all, let me tell you, what do you refer to the word alkyl halide? Alkyl halide, students, is your RX, and when you are doing ammonolysis, that means you are reacting it in the presence of ammonia. So you are going to take RX, then you are going to take ammonia. As you very well know, nitrogen can create 5 bonds. So 3 bonds if created with hydrogen, 2 electrons are left, and that is lone pair of electrons. And among Rx, we know, as per electronegativity difference, R carries a partial positive charge, X carries a partial negative charge. Coming to the fact that if I will be talking about nitrogen, this will be attracted towards the positive species, if you can very well observe. So what will happen over here? It's R that is attached. Now NH3 can be written as NH2H. And X is written as negative. Here nitrogen, when it has donated its lone pair of electron, carries which charge, beta? It will carry a positive charge, right? Because it has donated. Now coming to the next factor, if you will be observing, like what will happen next over here, my dear students, it's very simple. This X negative will go apart and this, it will take this H positive. So these electrons will break on to the nitrogen atom, creating your RNH2, hence HX is liberated out. Yes, so this is the creation of primary amines over here. I hope so this is clear to everybody. But before this step, let me tell you, let me introduce you a fact that over here, before coming to this part also, we have one more step that you can even mention as per NCERT. You have to react it with NaOH. When you are reacting it, it is positive, it is negative. So they will come out. It creates NaX. This OH negative will take this H positive, and now these electrons will break. So this is the best way to do it. Water will get liberated out and you will get what? Your NH2, primary amine. This is 1 degree amine. Now with the help of primary amine also you can create another kinds of amines such as secondary, tertiary and the quaternary. I shall be doing and showing you the secondary part. You can also do the tertiary and the quaternary on your own. Coming to the fact now that if I am writing my primary amine over here, it's RNH2. Now nitrogen again holds lone pair of electron, and here again I have Rx. That means I have taken the Rx, the alkyl halide, in excess. Coming to the fact that it is partial positive, it is partial negative, these lone pair of electrons shall move on to the positive charge, and what will happen next? Again the same thing, RNH2. So I can write RNHX and X negative like this. Here it is a positive charge because it donated its lone pair of electrons. Now beta, I am going to react it with NaOH, so it holds a positive and a negative charge. So as you can clearly observe, what happens next? This NaX will be liberated out, H2O will be liberated out, and you shall get what? Your RNHR. That means your secondary amine. Now that means if you have to create a tertiary amine, you can again react it with Rx. If you have to create a quaternary part, the quaternary salt, you can react the tertiary with the alkyl halide Rx. I hope so this is fine. Please kindly take a screenshot so that I can move on to the next method of preparation. Here comes next method of preparation, that is reduction of nitriles. So in reduction of nitriles, it's very simple, RC triple bond N. When you are reacting it with what? LiAlH4, lithium aluminium hydride. It's a very simple, just break the very first bond, give 1,1 hydrogen to both of them, break another 1,1 bond, give 1,1 hydrogen to both of them, you will get RCH2NH2. So this is your primary amine that is created. Yes, even students, what you can do is with the help of nitriles, you can do the Stephen reaction. Which reaction? The Stephen reaction. Stephen reaction is like SnCl2 plus HCl. What happens over here? Here you are not breaking two bonds. Remember the fact. Here you have to break only a single bond, give 1,1 hydrogen. You will get RCH double bond NH. Now students, you are going to do hydrolysis part, and what you will observe that this bond are now being broken up. Both the hydrogens are given to this and one oxygen to this. Water is being given, no. Nitrogen being more electronegative will gain 2 hydrogen atoms and it will form ammonia and it will form RCHO, that is your aldehyde. That is your aldehyde obtained. But as you very well know, my dear students, you need to obtain what? Your amines. So you have to stop this reaction over here only, and then you have to react again this with your SnCl2. If you do this, if you don't do the hydrolysis part and react again with SnCl2, this will get broken up, both will get 1,1 hydrogen, RCH2 NH2 will be created. So you need to know this fact that when you are doing the Stephen reaction, you don't have to do the full hydrogenation. This is full hydrogenation when you completely break all the bonds and give hydrogen to both of them. But in the case of Stephen reaction, you are doing this reaction twice because you don't want to obtain aldehyde, you have to obtain amines. Hence, you have to stop the reaction in between and again react it with SnCl2. I hope so this method of preparation is also clear to each and everybody of you. If yes, please kindly take a screenshot so that I can move on to the next example, next part. Now student comes reduction of amides. Now what is amides? It is RC double bond ONH2. This is what is amide. Let me tell you, you can convert amide into amines, but how, ma'am? You can take lithium aluminium hydride again over here, and what will happen next? This double bond O will get replaced with 2 hydrogen atoms and you will get RCH2NH2. So I hope so it is very simple and a very basic reaction. Yes? Okay. Now let's move on to the 5th method of preparation. Shall I? Yes, ma'am. Now beta comes the most important, that is Gabriel thalamide reaction. Coming to the Gabriel thalamide reaction, in your NCERT, they have started with the thalamide, but over here I am going to show you with thalic acid. You can add this step in your NCERT. This will be beneficial because all organic chemistry is related with each other, and in question paper they can give you conversion questions. They can give you such, in a such way that you can relate both of them. So why not just do with the help of the very first step, that is the basic step. You can just add it over there. So beta, this is your thalic acid, COOH. This is what your thalic acid. Let me tell you, when I am pronouncing thalic acid, P is silent over here. I can also represent this thalic acid like this, C double bond OH, C double bond OH. Yes, ma'am. Now see, what will happen next? I am going to react it with ammonia two ammonia I'm going to react it. What are you going to get? Both of the OH groups are going to get replaced with NH2. Both of them are going to get replaced with NH2. Now in the next step, my dear students, just remove one ammonia molecule. And when you are going to remove one ammonia molecule, you will get phthalamide. See what will happen? NH2H. Now you will get what? This is your benzene ring. This is your C double bond O. Here is your C double bond O. They both shall be connected with NH. And this is your beta phthalamide. This is your phthalamide. And in NCERT, they have given you reaction from here, from phthalamide. So this step you can add it over there. Now I'm going to do the next part from where we have to prepare your amines. You can even read the NCERT highlights that are written over here. Let's do this now. When we are taking phthalamide in your NCERT, they have started from here. So this is your phthalamide, C double bond O, C double bond O, NH. Now I'm going to either react it with KOH or with NaOH. So this is my first step. So let me tell you, when you're going to react it, you know K positive, OH negative, N negative, H positive. This two thing everybody knows, right? What will happen, ma'am? It's very simple. Water will get liberated out. Water will, ma'am, come out. What shall we be left behind? We'll be left behind with this factor that here is C double bond O, here is C double bond O, it's N negative and it's K positive. I hope so. This is a salt created and everybody knows this. Yes, great. Now let's see the next part. Now students, in the second step, you have to react it with Rx. With whom, ma'am? With Rx. And in Rx, as per the electronegativity difference, R will get a partial positive charge, X will gather a partial negative charge. Just understand this fact that this Kx will now come out. You will get what? You will get again C double bond O, C double bond O. Here will be N negative, R positive. Now you just need to do the hydrolysis and react it with KOH. See what will happen. It's very simple. These bonds will be broken up. They will get what? Now see, they will get two hydrogens, one over here and one over here, and they will get OH, H2, H2, right? But they were not going to create carboxylic acid again over here, phthalic acid. They will create a salt like this. And over here, it's RNH2 created out. So this is a creation of primary amines, everyone. This is Gabriel phthalamide synthesis, the most important reaction with regard to your chapter amines. You know, if I have to create your question paper, I am definitely going to give a question from this particular part. I hope so. This is fine. This is Gabriel phthalamide reaction. Let me show you the important key point that it is only used for the preparation of primary amines, not for any other compounds, not for aromatic, not for any other stuff. Only for primary amines. Yes, yes, ma'am. And also understand this fact that aromatic primary amines cannot be created, secondary amines cannot be created, only primary aliphatic amine can be created. Please kindly take a screenshot now. Let me show you the next important reaction with regard to your chapter, that is Hoffman bromamide reaction. Coming to Hoffman bromamide reaction, here you have to take amide, that is RC double bond O NH2. You have to react it with Br2 and NaOH. Now it's very simple, beta. You are going to get what? RNH2. And rest byproduct, if you want to remember, you can remember. It is Na2CO3, NaBr, and water is liberated out. I hope so. This is fine. But one special thing you can observe, here you had two carbon atoms and here you have only one carbon atom. So the thing that you can observe it here, one carbon, here one carbon less product is obtained. So this is a speciality of Hoffman bromamide reaction. I hope so. This is clear to each and everybody of you. This ends our methods of preparation of amines over here. Yes. Now comes your physical property. Shall I start with that fact? With that part? Okay. Coming to the next one about physical properties, it's very simple that if I'll talk about the lower aliphatic amines, that means I'm saying that the amines which contains lesser number of carbon atoms, I'm considering them. And if I am considering them, let me tell you, my dear students, the lower aliphatic amine here refers to the one which has less carbon atom. They are gaseous in nature. As you are increasing the carbon atom, they become liquid. The ones higher ones are liquid and more higher ones are solid in state. So this is about the physical state of all the amines. Okay, that is written like primary amines with 3 or more carbon atoms are liquid and still the higher ones are solid. If I'll be talking about an aniline and other aryl amines, they are colorless, but you know they get colored due to the atmospheric oxidation. So on storage, when you're keeping it and when oxidation occurs, they are going to change their color. They will become what? Like see, they will get color, but they are usually colorless. I hope so this is fine. Coming to the next factor about solubility, let me tell you this basic part that amines are the lower amines are not soluble in water. Okay, the very basic lower aliphatic amines. I'm not talking about, the aromatic ones. Let's first talk about the aliphatic one. Lower ones are soluble in water, but higher ones are not. Why? Understand, because carbon, if you are increasing the number of carbon atoms, hydrophobic part increases. Hydrophobic part increases. Now, what is hydrophobic part? That means something which hates water. If you're increasing carbon atom in something which hates water, it does not like water at all, how it will get soluble? So, it won't be soluble. It becomes insoluble. That means only the lower ones are soluble, but the higher ones are insoluble because the hydrophobic part gets increased up. So, this is written, the lower aliphatic amines are soluble in water because they can create hydrogen bond. However, solubility will decrease with increasing carbon atom due to the hydrophobic alkyl part, right? And when it is hydrophobic, it won't be soluble. Clear? So, the lower ones can only be soluble but not the higher ones. Yes? Okay. Coming to the chemical properties of amines, what I'm going to do is, I'm going to create a flow chart over here for you people so that you can directly learn all the chemical properties with regard to amines. First, the chemical property that I shall be discussing about is basicity. Let's discuss about its basicity. So, as you know, it's a revision video, so I'm doing in a one shot. Always remember that the basicity of amines beta is directly proportional to plus M and plus I and is inversely proportional to minus M minus I group. The first thing. Other than this, okay, other than this, if I'll talk about like if they are basic in nature, so what you can take a general example. You can create a salt and you have already done that. If you're reacting it with HX, let me take an example. If you're taking RNH2 and you're reacting it with HX beta, it creates positive, it's negative, its lone pair of electrons are already there, so it will go over there. You are going to create what? NH3 positive, X negative. So, it can create a salt, right? And when you are donating lone pair of electrons, let me tell you, that is your basic nature. So, that, yes, they are basic in nature. So, this is the very first property that I have shown you over here. Right. Now, let's discuss about the second chemical property. But before that, I want you people to write this property down over here. Now, let me show you the next property. That is when you are reacting it with whom? With CH3C double bond OCl. Yes. Now see, you are not preparing it. You are, let me first change the arrow. Like this is a chemical property. So if you are reacting it with CH3COCl, let me show you what exactly happens. Let me give you an example. If you have C2H5NH2, let's take this example, and you are reacting it with CH3C double bond OCl. This is negative, this is positive. It contains lone pair of electrons. Very simple. So it will go over here, it will go over here. What you will get? CH3CO negative Cl. Here comes NH2 and here is C2H5. Now just understand this fact that these oxygen negative charge will come over here and Cl will go apart. As this nitrogen has donated one electrons, so it gathers a positive charge. This H positive will go and these electrons will come over here. So what are you going to get? You will get CH3 C double bond O. This becomes NH2. Now no charge because H positive has gone, so it has given electron, it became neutral. Here it is C2H5. So this kind of an amide is also created over here. right? I hope so this is clear. I hope so this is clear. So what are you going to get? Like here it is CH3, C double bond O, NH2, and if you're taking R group, here R group will come with it. I hope so this is fine to everybody. Yes, yes ma'am. If you're reacting it with CH3Cl and KOH, CHCl3 sorry and KOH, this is carbylamine reaction, or I can say isocyanide test. So you are going to get this isocyanide, Rn triple bond C. This is also one of the chemical properties of amines, I would say. Everyone please kindly write this down. If you are doing the bromination of this Br2 with water, so what exactly will happen? Like you're taking up aromatic case. Now here I'm talking about aromatic amine. Okay, so what will happen, like aromatic amine, this is aniline, right? So Br2 will gather at all the position, ortho and para. But beta, if you are taking Br2 with CCl4, you will only get an ortho plus para product. Ortho plus para. Yes, plus I am writing the another product like this. Yes, if you are doing, you are reacting it with HNO3 and H2SO4, let me tell you, you will get all the three products. Here it's NH2, here it will be NO2 at the para, at the ortho, as well as NH2 will come, as well as at the meta. This is a very different case when we are taking HNO3. And in the case of, and if you are taking H2SO4 and H2SO4, here's bitter ion will be created. Let me show you how. It is NH2, here SO3H will come. Now the next step is quite different. This beta H will go over there. You will get a zwitter ion, NH3 positive, SO3 minus 1. I hope so all of these reactions are now helpful for you to remember, because I have created a flow chart. Kindly write this down. Now I am coming to the last part, that is your diazonium salt. I hope so this is fine. Yes, I hope so this is fine. Let's discuss about beta now the diazonium salt. See, when I am saying diazonium salt, understand the fact that di here stands for 2, azo stands for nitrogen, em stands for positive, and if you are taking salt, it will also have a negative 1. Yes, yes ma'am. Now, for example, if you have your primary aromatic amine, that is NH2, this is your primary aromatic amine. Primary aromatic amine. And beta, you are reacting it with NaNO2 and HCl. Diazonium salt will be created. N2 positive, Cl negative. This is what is diazonium salt. This is what is diazonium salt created. I hope so this is fine. I hope so this is fine. N2 positive, Cl negative, Em salt. Yes? Yes? This is the method of preparation. Now let's talk about the chemical properties of diazonium salt. Let's talk about the chemical properties it is like this, no? N2 positive, Cl negative, or X negative you can say. See, if you are reacting it with what? Now see, if you are reacting it with Cu2, Cl2 and HCl, you will create a chlorobenzene liberating N2, and this reaction is your beta Sandmeyer reaction. This reaction is your Sandmeyer reaction. Let's take one more case. If you are reacting it with Cu2, Br2 and HBr, you will get a bromobenzene liberating N2. Here one thing you can do is you can take X negative. So that will be much better, no? Yeah. So they both are Sandmeyer reaction again. They both are Sandmeyer reaction. Now, if you are taking Cu with HCl, this is your Getterman reaction. Okay. Here also you will obtain chlorobenzene liberating N2. If you are taking Cu with HBr, this is again your Getterman reaction. You will get bromobenzene with HCl. Students, if you are taking Ki and heating it, you will get iodobenzene. Yes, if you are taking HbF4, you will get fluorobenzene. Yes. Now let me show you the coupling reaction with diazonium salt. Shall I? Let me show you the coupling reaction with diazonium salt. Please kindly take a screenshot of this part. Please kindly take a screenshot of this part. Two more reactions are there, that is coupling reaction. Let me show you that as well. So when I will be talking about the coupling reaction, beta, so this is your diazonium salt, N2 positive, Cl negative. You are reacting, let's take with aniline. First is we are reacting it with aniline. This is aniline. And this is your diazonium salt. And this is your coupling reaction. It's a very simple beta. It contains hydrogen, no. So this HCl will be liberated out. This HCl will be liberated out and a dye will also be created. You have to name which color dye will be created, which I am creating. It's N, double bond N, and then you have here NH2. Okay, you have to tell which color dye it is. Now, there is one homework question for you people. One homework question for you people. First is write down the coupling reaction with phenol. Second homework question is name the dyes and the color of both. Okay. Third is read physical properties of diazonium salt from NCERT. Fourth is cover questions from the NCERT. That means do NCERT back exercise. I hope so this is clear. Yes, so beta, this ends your one short video lecture for the chapter Amines. I hope so it was helpful to each and everybody of you and you really enjoyed this particular class. Please kindly make this short notes and even you can create such flow charts so that organic can be more easy for you people. And all the best, all the very best for your upcoming exams. Thank you so much, my dear students, and please do cover the homework part that I have already given you in the last slide. And we shall be meeting in the next lecture. Till then, keep smiling, keep learning, take care of yourself. Bye-bye everybody. Thank you.